Wonderful evening, my dear students. I'm your physics teacher. So today we are going to discuss few basic things in physics which you have to know if you're starting 8th or ninth grade. Okay, let's see. Okay, so before we go on, please hit the like button and subscribe to my channel if you like my explanation based on my further videos or based on the further explanation. Okay, let's get started. Now I'll share my screen and let's discuss. Okay. Okay, here we are. So today's basic topic is about basic mathematics, which comes under math as well as physics. So in this chapter, we have divided this into two parts. It's divided into two parts, as I said, trigonometry and vectors. So we have subtopics in trigonometry as well as. So let's try to complete trigonometry in two videos because it's a big lesson and we need explanations. Okay. So, and then we have vectors, which is small. We can complete it in one video mostly. Okay. So for these two lessons, I will explain you guys. This whole can take like like 3 to 4 videos, like 2 or 3 for explanation and 1 or 2 for textbook exercises. Okay. Now let's see. Coming to trigonometry, our today's topic, which we're gonna commonly discuss about. So, without seeing towards your slide, can you guess trigonometry, like the definition of trigonometry, without looking it into the slide? Okay, so trigonometry can be also known as the study of triangles, where you try to find solutions for many different parts of a triangle. Okay, so let's see, where is it used? I mean, why are you studying trigonometry? You have to use it somewhere, right? So, without, if you don't want to go into the textbook knowledge and, spread across far in the world, then you can see that trigonometry is used everywhere. And example, pilots need it to correctly see the location of aeroplane, where do they have to, which direction should they ride, etc. So and so it is used in astronomy, etc. Engineers use it. It's very important subject. So let's discuss more about it. Coming to our slide definition, the word trigonometry is derived from two Greek words meaning trigon, meaning triangle, and metric, meaning measure. So, as I said, the basic thing why we are studying is to find the solution of triangles or finding unknown quantities of a triangle. Okay. Now, coming to where do we use it? Applications. It is used in astronomy, navigation, engineering, etc. Okay, so we are clear with the word trigonometry. Now we'll see the starting basic definition which you need if you want to learn about trigonometry. Now, trigonometry is all about triangles. So in this video, we are going to mainly discuss, deal with right angle triangles, because it is the only type of triangles where we can use Pythagoras theorem, right? So we'll see about that further. Now, before that, you have to know the definition of an angle, right? Now, to find the definition of an angle, please look into the slide. The amount of rotation of the revolving ray with its reference to the fixed point. Now, example, let's say this is the fixed point on x-axis. Let's say it's x is the fixed point. Now, okay. Now, there's a revolving ray which is at its position like this. Now, from this position, it revolves and come until here, like this, right? So, they're telling an angle is nothing but the space between these, and it is usually represented by theta. I hope you're clear with this. Now coming to trigonometric ratios. Okay, before that, another basic thing you have to know, this is a right angle triangle. This is 90 degrees, and you know what is hypotenuse. And based on the theta, we are seeing from the perspective of two different angles, right? One is theta and one is 90 minus theta. First, if I'm going to see with theta, theta is nothing but any angle. Okay. Now, the formula of hypotenuse we know is h square is equals to a square plus b square. Am I right? So, with using this formula only, we find many more. Now, if you want to find a particular value, if you want to find any other value, we have few ratios. We have few ratios to find. Now, everything to find will have some ratios. Now, ratios example can be here hypotenuse by opposite, or we can have opposite by hypotenuse, or you can have adjacent by hypotenuse, or hypotenuse by adjacent. There are many, right? So as there are many, I would like to discuss this 1 second. We'll see these three first. Opposite by hypotenuse, adjacent by hypotenuse, or opposite by adjacent. Opposite by adjacent. All of these are ratios to find a particular value, right? Now, these ratios are also given a name. These ratios are given few specific names. Now, opposite by hypotenuse is nothing but sine theta, as we can see it here. Okay, perpendicular or opposite is the same. Then, adjacent by hypotenuse is known as cos theta, as you can see here. Cosine theta, cosine or cos, short form, sine theta, cosine theta. Then opposite by adjacent is tan theta or tangent theta. Clear? So these three are the values which we know. Then from these three values, you just flip them. So opposite of tan is cot, then opposite of sine is cosecant, and opposite of cos is secant. Same, but flipping them will give you other three values. So overall, you have 60 trigonometric ratios to find out a particular value. Clear? Clear with the slide? Now the next one. We will see trigonometric ratios for a few specific angles. Now, we are taking an isosceles triangle here, meaning this and this, these both are same, right? Isosceles triangles, we know the properties. This and this can be same, right? Now, coming again. Okay. Here we have few values. They're telling the hypotenuse is equal to a root 2, and adjacent is equals to a, and opposite is equal to a. But from the perspective of this theta, we are taking 45 degrees theta here. Okay. Now, sine 45 is equals to opposite by hypotenuse. Opposite a by hypotenuse a root 2. Now, a gets cancelled, so you'll have 1 by root 2. Like that we have done for the rest. I'll show you this one. We'll find out for the rest. Clear? This is done. So, same using the formula, you find cos and tan, etc. Then this is your homework to find for 30 degrees where the diagram is given, and 60 degrees. Okay, after that we have the table here, trigonometric table, from where you have to remember the values. So derivations are not that important, just for you to understand. So just remember the trigonometric table and we are be done with our work. Coming to sine, so this trigonometric table is hard. Do you think so? There's a simple trick for this, if you want to understand. Very simple trick. We'll see that. Okay. Now, 1 second. Yes. So as you can see that sine 0 is 0, sine 30 is 1 by 2, sine 45 is root 1 by root 2. It's actually 1 by root 2. This is also the good value. 1 second. Either whatever, like this can be written as root 2 by root 2 into root 2. So this gets cancelled. So it's either way 1 by root 2. 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Now, as I told, I'll tell you a trick to easily remember all of these. Very smart, am I? Okay, let's see. Okay, so first, the basic thing you have to remember is sine, like sine values for all these angles, whatever we have right now. Okay, then the next thing, cos is nothing but inverse of all of these. Not inverse, but flipped away. So, as you can see, the values, they're ulta of whatever is there, right? Then tan is nothing but sine by cos. Tan is equals to sine by cos is equal to tan. Clear? Remember, 0 by 1 is 0. 1 by 2 divided by root 3 by 2 is 1 by root 3. And 1 by root 2 divided by 1 by root 2 is 1. And root 3 by 2 divided by 1 by 2 is equals to root 3. And 1 by 0 is equals to undefined. Am I right? So with this, we are already getting three values, sine, cos, and tan. Then flip the values, whatever you get, to get the rest three values. Done. You can easily remember the trigonometric table and write down. Okay. So the next thing we'll see. Okay. Before that, until now, we have seen about the angles from one observation. Okay. We have seen angles until now from A. We can see from 90 minus A. So if we want to find values of 90 minus A, sine theta is equals to cos 90 minus theta. Sine of whatever value you'll get for sine A is equals to cos of 90 minus A. Clear? Like that, cos theta is equals to sine 90 minus theta. Tan theta is equals to cot 90 minus theta. Cot theta is equals to tan 90 minus theta. And secant theta is equals to cosecant 90 minus theta. And cosecant theta is equals to secant 90 minus theta. Just few formulas to know. Remember, that's it. Next, we'll see opposite angles identities. Opposite angles identities is nothing but if the theta is negative for few ratios, most every ratio, you send it to the outside. That's what you'll get minus sine theta. But for cos and secant theta, plus if it's minus, if it's negative, it will become positive. The rest all, the minus sign for theta goes to the outside. Clear? Next, so you want to know why do we get minus theta? If you want to know why do we get minus theta, you have to know the trigonometric ratios plane. Or do you know xy axis, right? So let's take it as like that, 0, 90, 180, 270 degrees. So if the ray is here or somewhere between 90 to 0, all whatever ratios we have are positive. Okay. If the ray comes towards 90 to 180, then only sine and cosecant are positive. Yeah. When it comes this side, tan and cot are positive. When it is in between 272 to 360 degrees, then it is cos and secant are positive. So for this, what you have to remember is all silver tea cups. For everything, see the first letter. All. S means sine and cosecant. T means tan and cot. Cup means C, means cos and secant. Clear? Now, as we can see from the text here beside, sine, if n is nothing but a multiple of 90, you'll understand when I'm doing few problems. I'll show you how to do. If the n is an even number, there's no change. If it's a negative number, there is a change. Sine will become cos, cos will become sine, tan will become cot, like that. Okay. Now I'll tell you with the formula, as this is going to be our last two slides. I'll tell you with the formula. We'll do it here, okay? Let's do it here because we have free space. Example, let's take. Okay, I'll give you questions from my textbook. Let's solve few questions from my textbook, so you know you'll be clear with it. Okay, so as you can see, yeah, I'll go with cos minus 330. If you take cos minus 330, convert 330 into the multiples of 90 plus something or minus something. So, as here it is minus, and we have learned in a previous one, yeah, sorry, here only, cos will, if it's negative, it will become positive. So, this is nothing but cos 330. Cos 330 can be written as, yes, it can be written as 360 minus 30. Okay, 360 minus 30. Am I right? Now, 360 can be written as 4 into 90 minus 30. Am I right? This is cos, overall cos. Now, as 4 is an even number, n is an even number, there is no change in the ratio. So, you'll get cos 30. What is cos 30? Is equals to root 3 by 2. Root 3 by 2. And sine, if you're coming to a sine, from this you can see 330 means it's 360 minus 30. So it will lie somewhere here in this coordinate, fourth coordinate. For fourth coordinate, the ratio cos is positive. So you will get a positive root 3 by 2. Clear? That's how you solve. Now I'll show you with another example. Now make it clear. Okay. Now, we can go with sine 150. Or else wait. Um, yes. Let's go with cos 150. Cos 150. Cos 150 can be written as cos 90 plus 30. Sorry, 90 plus 60. 90 plus 60. Am I right? Now, as it is 90 plus 60, we will see 1, right? If it's like this. So, as 1 is an odd number, this sign will change into cos. Sorry, cos will change into sine. So, sine 60. And 150 lies in the second coordinate. Where is it? Yes. 150 lies in the yeah, 1 second. Yeah, it lies in the second coordinate where sine and cosecant are positive. But cos here is not positive. Hence, you will get a negative root 3 by 2. Clear? I hope you are clear and you got a pure understanding for opposite angle identities and trigonometric ratios table. Now we will see about compound angles formulas and multiple and submultiple angles. Okay. Now compound angles, we have these are random formulas to remember, which you have to remember. No derivations. Sin A plus B. Formula is sin A cos B plus cos A sin B. Cos A plus B is equals to cos A cos B minus sin A sin B. Tan A plus B is equals to tan A plus tan B by 1 minus tan A into tan B. Tan A minus B is equals to tan A minus tan B by 1 plus tan A into tan B. So then we have cot. Cot A plus B is equals to cot A cot B minus 1 by cot B plus cot A. Cot A minus B is equals to cot A into cot B plus 1 by cot B minus, see the signs, minus cot A. Then sin A minus B is equals to sin A cos B minus cos A sin B. Cos A minus B is equals to cos A cos B plus sin A sin B. Clear? Clear with the compound angles formulas? Remember, that's it. Then multiple and submultiple angles. Sin 2 theta. Sine 2 theta can be written as sine theta plus theta, or sine theta plus theta is equals to sine theta cos theta. Okay, we'll see like this. 1 second. Let's make the thetas like sine A plus B. If you take sine A plus B formula only, see, we have 2 sine A. 2, the theta is same here, so A. 2 sine A cos A. 2 sine A cos A, right? Sine 2 theta is equals to 2 sine theta into cos theta. Clear? Now cos 2 theta is equals to same. It's A plus A. So 2 cos, yeah, you'll take it as theta minus theta, because yes, it's 1 second. Yeah, cos 2 theta is equals to cos 2 theta is equals to cos square theta minus sine square theta 1. That is nothing but 2 cos square theta minus 1. Okay. Then tan 2 theta. Tan 2 theta is equals to 2 tan A by 1 minus tan 1 minus tan square theta. Tan square theta. Sorry for the mistakes. Sine 3 theta is equals to 3 sine A minus 4 sine Q by A. Okay. 3 sine A minus 4 sine cube A. 4 sine cube A. Okay. Cos 3 theta is equals to 4 cos theta, 4 cos cube theta, cos cube. Cos cube theta minus 3 cos theta. Tan theta. Tan 3 theta, you can solve it on your own actually. Yeah, you can take a formula. I want this as a homework to be done. Okay. So we are done with multiple and submultiple angles, and our trigonometry half part is done. Okay. Now we are done until this. In my next video, we're gonna see about slope of a line and straight line equation and textbook exercises. Bye for now, guys. If you like my explanation, please subscribe to my channel. Thank you.